Better now. So, let me start with a simple one here. So we have the equation there, 2 to the x equals 8. Right? So consider that equation, 2 to the x equals 8. All right? What's the solution to this equation? Or what's a solution? What's the solution? What's the solution here to this equation? What value of x would make this equation true? 3. That's right. It's 3. Okay? Why? Why is 3 the answer here? Yeah, because 2 to the third, right, would give us 8, so it's got to be x is 3. Okay? If you have a hard time seeing it, another way we could write this, right, is that 8 is 2 to the third. So another way we could see this is we could say, okay, 2 to the x, well, is still there, right? 8 is the same thing as 2 to the third, right? So we get a common base here, right? They both have a base of 2. And we're trying to say that the left-hand side is equal to the right-hand side here. So if this is equal to this, and they have the same base, that means they must also have the same exponent, right? If they're going to be equal, you have to have the same exponent. There's no other exponent here. 2 to that exponent will give you 3. Okay, so in other words, it's got to be, x has got to be 3 there. Okay? So that's what we're going to be looking for here. Okay? The key here is to rewrite the equation using a common base. Common as in shared, right? Okay, we're going to rewrite the equation using a common base. That's going to be our strategy here for all of these equations. Okay, so let's try another one. Again, our directions will just be like solve for x. Now, what's going to be important is that we need to be able to recognize what common base to use, right? So, for example, okay, 8 to the x equals 2 to the 6th. 8 to the x equals 2 to the 6th. Okay, what's going to be our common base that we're going to use here? What number are we going to use for our common base? We have 8 as one base over here to the x. We have 2 as a base over here to the 6th. Okay? What's going to be our common base here? 2. Right. Why 2? Because 8 is a power of 2, right? We can rewrite 8 as a power of 2. 8 is 2 to what exponent? We just saw it, right? 8 is 2 to the third. That's right. So we're going to rewrite this 8 here as 2 to the third. But then remember that 8 was being raised to the x. So it's 2 to the third to the x equals 2 to the 6th. All right, now we have to think back to our exponent properties that we talked about, what, 2 units ago? Okay? When you have a power raised to another power, right? So I have cubed, but then to the x as well. How do you simplify the exponents when you have a power raised to a power? What do you do with those exponents? AJ, I think we should put the computer away, by the way. Oh, he can't even hear me. Yeah, it's even more of an encouragement then. You might want to put the computer away, AJ. I think it's too much of a distraction. I actually said something to you and you couldn't hear me, so I'm a little concerned you're not going to be learning anything today if you don't do that. All right. So, when we have a power raised to a power, what do we do with our exponents? Yes, multiplication. 2 to the 3x equals 2 to the 6th. Good catch. All right. Yes, multiply the powers together. Okay. Now, we have the same base. 2 to the something equals 2 to the something, right? So what must be true here? What else has got to be equal? If 2 to the 3x is equal to 2 to the 6th, then what must be equal? 3x has to equal what? 6. Yeah, the other exponent there. Exactly right. It's got to equal the other exponent. And so now we have a simple equation to solve here, right? What we do to both sides to get x by itself? Divide both sides by 3, right? And so we get x equals 2. All right? Let's check it just to make sure. You don't have to in these cases, all right? But I'm just going to do it just to make sure. So 8 to the 2, right? X is 2. So 8 to the 2 says it's 64. 2 to the 6th. Hey, 64, look at that. Okay? It worked. All right, let's try another one. Same thing, solve for x here, right? 9 to the 2x, 27 to the x minus 1. Okay. 9 to the 2x, 27 to the x minus 1. Okay. Is 27 a power of 9? 9 to what power will give us 27? Well, think about that. 9 to the first power is 9. 9 to the second, that's 81. 9 times 9 is 81. So is 27 a power of 9? Not like a nice power of 9 here. So like over here, right, we could rewrite 8 as a power of 2. That was pretty easy, right? But over here, these two are not nice powers of each other, but they're both powers of what number? 3. So our common base here, right, is not given to us. Right here, we could rewrite 8 as a power of 2, and we had a 2 here. But here, 9 and 27, neither of those can really be written as powers of each other, so we have to go to a different common base here. They both are powers of 3. 9 is 3 to the what? 3 squared, that's right. So it'll be 3 squared to the 2x, and then 27 is 3 to the third to the x minus 1. Okay? And when we have a power to a power, what do we do with our exponents to simplify them? We're going to multiply them. We'll divide in a second here. But 2 times 2x, 4x. What about here? When I go to multiply here, what gets multiplied with 3? My exponent here at 3. What am I going to multiply it with a 3? The x or the minus 1? Both. Good. Very good. Yes. Distribute it. Okay. So 3 to the 4x equals 3 to the 3x minus 3. Doing better now, Patrick? Doing better now? Okay. All right. Common base. Now we can set our exponents equal. 4x equals 3x minus 3. Solve the equation. What should I do for my next step here? Subtract 3x on both sides. Okay, I get x equals negative 3. There's my answer. Okay? Now if you don't believe me, okay, 9 equals 2 times negative 3, right? I put negative 3 in for x, I get that 1.8816 e negative 6. Okay, and we'll do 27 to the negative 3 minus 1. And look at that. Same decimal. Same decimal, right? You can hit, I don't know if yeah, sometimes the decimal is too small even for the calculator to convert it to a fraction, so I didn't even want to do that, okay? Sometimes, I mean, it still could be written as a fraction, it's just, it's so small the calculator won't do it for us. All right, let's try one more here together, and I'll have you guys try one on your own. All right, one more here together, and I'll have you try one on your own. 81 to the 3 minus x equals 1/3 to the 5x minus 6. What's our common base going to be here? What number are we going to use for our common base? 81 is one of our bases. 1/3 is another one of our bases. What number can we use as a common? What number what number has 81 as one of its, multiples? 8? Okay, so yeah, 9 squared is 81. What about 1/3 though? How do you get, what power of 9 is 1/3? 9 to the third wouldn't be 1/3. 9 to the second would be 81. Wait, negative what?
2.
Ah, okay, so 9 to the negative 2, that would give us 1 over 81 though. That wouldn't give us 1/3.
Negative 3.
Okay, so negative 3 would give us 1 over 243, I think, or something like that. Or wait, no, that would be, nope, that's wrong. 9 to the negative 3 would give us 1 over 729. Maybe we shouldn't use 9 as our base. 81 and 1/3 are both powers of not 9, but 3. 3, okay? 3. And common. Yes, 81 is a power of 9, but 1/3, and you can rewrite 1/3 as a power of 9, but it's like a little bit, I think you make it more difficult for yourself. Let's make it 3. Okay, so 81 is 3 to the what? 4th power. What's 1/3 though? 1/3 is 3 to the what? Yes. 1/3 is 3 to the negative 1. Remember, folks, those negative exponents, they flip our base and make fractions, right? So 3 to the negative 1 is the same as 1 over 3 to the 1. Right, I'll write that over here on the side. 3 to the negative 1 is the same thing as 1 over 3 to the 1. 3 to the negative 2 is the same thing as 1 over 3 to the 2, or 1/9. 3 to the negative 3 equals 1 over 3 to the 3rd, or 1/27, etc., etc. Okay? So on and so forth. Okay? So, that's what we have. 1/3 is 3 to the negative 1. Okay, now, power to a power, we'll distribute there, right? So 4 times 3, 4 times minus x, so we'll have 3 to the 12 minus 4x. Whoops. Almost distributed the wrong number there. And then negative 1 here, we'll have 3 to the negative 5x plus 6. Okay. And now we can drop our bases there and just set 12 minus 4x equal to negative 5x plus 6. And then you guys can solve from there, right? Well, let's see here. I'll add 5 to both sides. And then subtract 12 from both sides. And you get x equals negative 6 as your answer there. Okay, and if I type it in, 81 to the 3 minus negative 6, I get that decimal. And then 1/3 to the 5 times negative 6 minus 6. Again, typing it in my calculator. And you see you get the same exact decimal. Okay? About 1.5, but not exactly 1.5. Oh, wait, but it's e to the 17. Never mind, it's a gigantic number. Okay? You guys know what that e17 means? It's the way for the calculator to do scientific notation. Okay? It means, so e17 means this number times 10 to the 17th. Okay, this number times 10 to the 17th. Okay, so in other words, you're going to move that decimal to the right 17 times, and that'll give you the actual number there. Okay. All right, here's one for y'all to try. See what you can do here. 100 to the 7x plus 1 is equal to 1,000 to the 3x minus 2. Okay, so go ahead and give that one a try. Think of a common base there that you could use, and then rewrite in terms of the common base, and then go from there. Yes? Okay. Anyone need any help? Help.
Does anybody want to use true?
I'll explain what it is.
Anyone else want to use snake back if you want to use? Anyone else still need one of these? The yellow reviews, green.
I'll give you like one more minute here, one more minute. Work this out. If you need some help, let me know. I'm around to help too. Come take a look at something. Yes, Wyatt. Okay, first that looks great. 2 times that, 2 times, so grab let's multiply, right? 2 times 7, that's 14. What's 2 times 1? So it should be a 2 times 3. Let's just check here. 3 times 3 is 9. 3 minus 2 is minus 6. That looks good too. So now you just subtract the 2 over, and then we're just solving for the x there. Right, just gonna be x by itself. Okay. There's what you should have gotten. Negative 8/5 is what you should have gotten there. Negative 8/5. Negative 8/5 for your x value. Okay. Questions on that? Common base here is 10. Okay, 100 and 1,000 are both powers of 10, so 10 squared and 10 cubed. The 2 distributes to the 7 and the 1, so you get 14x plus 2. The 3 distributes to the 3x and the minus 2, so you get 9x minus 6. They have the same base. They're equal, so we're going to set the exponents then equal. Okay, subtract the 9x over, you get 5x. Subtract the 2 over here, you get negative 8. And then you divide both sides by 5. Negative 8/5 is your answer. Okay. I want to do one more together with you here. One more together with you here, and then I'll let you guys get started on the assignment here. I'll get you guys started on the assignment. Yeah. Okay. One more here. Yes, I know I'm going to use another. Actually, you know what? I'm just going to squeeze it in over here. I'll just fit it in right over here. Okay. Okay. Seven to the third for the x times 7 divided by 49 equals 1. What's going to be our common base here? What number should be our common base here? 7. Yeah, 7. Very good. Okay. See, that's pretty easy, right? 7 is already to the third here. It's 7 to the 1 right there. 49 is 7 to the what? To the 2. Ooh, but what about 1? Is 1 a power of 7? Seven to what power would give us 1?
One's on 7.
What's that?
Can't you just leave 1 alone?
So we could leave 1 alone. We could. You could get away without having to change that 1. But it is a power of 7. It's 7 to the 0. Right? Any number to the 0 there is going to be 1, except for 0 to the 0. 0 to the 0 is an indeterminate form. It doesn't necessarily equal 1. Okay? But any other number besides 0 to the 0 power is going to give us a 1. Okay? So, wow, everything's in terms of 7. So now let's start combining things together here. Okay, we have a power raised to a power, right? So this has become 7 to the 3x. Now, when we multiply two numbers that have the same base, what do we do with their exponents? Add them. But these are not like terms. It's not going to be like 3x plus 1 is not going to be 4x. So what I'm going to have to do is I'm just going to have to rewrite 7 to the 3x plus 1 exponent all over 7 to the 2 like that equals 7 to the 0. Okay. Now we're dividing. What do we do with our exponents when we divide? We subtract our exponents. So I have 3x plus 1 take away 2. I'll write this out explicitly here. Okay, I'm going to write it out explicitly. If you guys can just do the subtraction in your head, feel free on your own. Okay, but I'm just going to write it out explicitly there. Dividing numbers that have the same base means you subtract. So 3x plus 1 minus 2 is what we get right there. So now I'm just going to simplify that. 3x plus 1 minus 2 is 3x minus 1. Okay. Same base on each side. 3x minus 1 equals 0. So x will be 1/3. Okay? X will be 1/3. Add 1, divide by 3, right? Okay. So, I've got some practice problems for us here for the homework, okay? But you have almost like 25 minutes to work on this, okay? And so you should be able to get it done by the end. I'm not going to assign all of these problems because there's a lot here, but I am going to assign a few. So let me just, I'll write out what I'm going to assign here first, and then I'll pass out the sheet here, okay? So let's see. So the homework, there's the solving exponential, solving simple exponential equations worksheet. Yep. Yeah, go ahead. Okay. And let's see here. What do I want to give you? Sure. All right, we'll just say numbers 1 to 23, every other odd. Do you know what I mean by every other odd? So like you'll do number 1, and then what's the next one that you'll do? 7. So the odds go 1, 3, 5, 7, 9, 11, 13, right? So if we do 1, then you're going to do 5. And then you're going to do 9 and 13 and so on and so forth, okay? I say that now because students get really mad when they do more problems than they were supposed to do. So anyway. That's what I mean by every other odd, okay? And I think it should go, yes. Okay, that should work, I think. Okay, so every other odd. Just try to give you like a nice, of course, if you want to do more, you're more than welcome. Tatum thinks she might have some trouble going to sleep tonight, so she's going to maybe work on some of it before bed, so she gets a little time. Okay. Oh, because, yeah, I cut off number 14.